Again, these are more difficult because they're asking me to, get the derivative of a quotient now. And let me write it down for you. So I'm going to write down a little different. I'm going to use a different definition. I've been using this a lot. I've been using f prime at a is equal to limit as h goes to 0, f of a plus h minus f of a over h. I've been using that a lot. I want to just use a different definition. And again, as I said in the prior problem, it's nice to have options. And I'm going to write down, f prime at a is equal to the limit as x approaches a, f of x minus f of a over x minus a. I'm going to use this one now. Let's write this down. F prime at minus 7 is going to be equal to the limit as x approaches minus 7, f of x minus f of minus 7 over x minus a minus 7, which is x plus 7. Let's go to town on it, see what we get. Limit, x goes to minus 7. And again, I do know the function. I put this over here, x plus 7. The bottom's not much I can do about. What do you get on top? You get 1 over x plus 9. And then you get minus 1. I'm going to evaluate the function at minus 7. Well, it's going to be minus 7 plus 9, which is 2. What I'm going to do now, multiply the top and the bottom by the minor LCD. Let's write it down. What do you get? X plus 7. The minor LCD is going to be 2 times x plus 9. All right, when you multiply the top by the minor LCD, you're going to get, 2 minus x plus 9. All right? Okay, what do you get now? You get limit, x goes to minus 7. Let me just stop for a moment and say a lot of students, what happens when they get confused by this because they don't know what the question is anymore. You can always go back and read it if you have to. But right now, I'm just simply trying to see if I can do the limit. And what do I see over there? I actually see, if I saw that, it's minus x. Let's see, minus 9 plus 2, which is minus 7. So I'm going to say minus x plus 7. That's what the top reduces to, all right? So what do you get in bottom? You get x plus 7, you get a 2, and you get x plus 9. What happens over here? Let's take a look at that. And what do we get? I mean, one thing for sure, if x is going to minus 7 but is not minus 7, these things are not going to be 0. And what do I get now? I use limit loss now. I get minus 1. What do you get on bottom? 2. And I'm using limit loss. What do you get? Minus 7 plus 9, which is 2, which you get minus 1/4. All right, so I'm going to say I got that. I think they asked for that. Use a limit definition to compute the function's derivative at minus 7. We just did that, and it should be minus 1/4. And I see it's over minus 1/4 over here. What's the other thing they asked for? What's the equation of the tangent line at minus 7? So let's write this down. So it's going to be, the point's going to be, let's see, minus 7. Plug in minus 7 to that point, you get 1/2. I'm plugging it in here, by the way. What's the slope going to be at this point? Well, we just computed it. It's minus 1/4. I'm going to write it down for you now. And that's going to be y minus 1/2 equals, the slope is minus 1/4. And then you're going to get x minus minus 7, which is x plus 7. Now, I'll be of the opinion, I actually like this equation better. I mean, to me, it's easier to look at that. Do I see that being listed over here? I do see that being listed over there. Be aware, though, that you may have to rewrite these guys depending. Like it's a multiple choice exam, you might be shocked how they rewrite these guys. And you have to be able to look at that pretty quickly. So I'm going to say I'm in agreement with everything so far, but I do want to go through the simplification process with you. All right? So let's take a look at it. What I'd probably do is multiply both sides by 4. You get 4y minus 2 equals minus x minus 7. And then what I would probably do is add 2 to both sides. 4y minus x minus 5. Then what I do is divide both sides by 4. What do I get? Minus 1/4 of an x minus 5/4. Is that listed in the key? It is. I do see the minus, it's right over here. Minus 1/4 x minus 5/4. All right, thank you.